Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing BGP, concepts, configuration, and monitoring in Junos. In this lesson, we'll be covering the 4 message types that BGP uses to establish and maintain peering relationships and exchange routing information. Overall, BGP is a pretty simple protocol. Since it uses TCP port 179 for communication, it doesn't need to implement its own reliable communication protocol, allowing for the communication mechanisms in BGP to be simplified. Let's jump on in and take a look at the 4 message types used by BGP. The 4 message types used by BGP are the open, update, keep alive, and notification messages. The open message is only exchanged during the formation of the peering relationship. In a future lesson, we'll review the states that a BGP-speaking router may be in, and one of them is open sent, referring to the open message having been sent but no response received yet. The BGP update message is used to exchange routing information. We'll review each of these message types and their format in detail in the later slides in this lesson. Now, just like other dynamic routing protocols have a mechanism by which they declare a neighbor relationship is down if they haven't heard from the other router for a certain period of time, BGP also has this function. BGP-speaking routers must exchange keep alive messages. The update message, however, will be counted as a keep alive when it is received. And finally, we have the BGP notification message. This message function is a bit non-intuitive for its name. The notification is used during the teardown of a BGP peering session, though we'll talk about it in a bit more detail in a later slide. Before we review each of these message types in more detail and their formats, let's take a look at the common header included with all BGP message types. The BGP header consists of 3 fields: the marker, length, and type fields. The marker is simply 16 octets set to all ones. The length field describes the length of the BGP message. This is important as some of the messages may be variable in length. Finally, the type field describes the BGP message type that is being transmitted. The header is 19 octets long and is included in the beginning of all BGP messages. So, let's review the first message type, the open message. As I mentioned earlier, the open message is only used during the peer establishment. The BGP-speaking routers exchange open messages to ensure each other are capable of the necessary features and that one another are configured correctly. As part of the manual device configuration needed to establish a peer, the network administrator must include what the autonomous system is of the configured peer. The open message includes the sending router's configured autonomous system number. When received, the receiving router compares this to the configured autonomous system number for the peer to ensure they match. If they do not, BGP will not establish the peering. The open message also includes any extensions or features that the local router supports. This can be multi-protocol features like IPv4 or IPv6 routing information and Layer 3 VPN or Layer 2 VPN information. Moving down to the packet format, we see that the protocol version is in the first octet. The local autonomous system number is included in the following 2 octets. The configured hold time is the next 2 octets. The hold time does not need to match between the devices for them to establish a peering. The lower of the two hold times is the one that will be used for the BGP session if they are different. The following 4 octets is a field labeled as the BGP identifier and is the local router's configured router ID. This is typically the loopback address of the router. However, a different router ID may be configured in Junos. The last 2 fields are regarding the BGP extensions that the device is capable of. The first octet is the length of the optional parameters field, and then the last field is variable length and includes the optional parameters, which are the features or types of network layer reachability information that the device is capable of exchanging with BGP. Great. Let's move on now to the update message. The BGP update message is at the core of the routing information exchange in BGP. The update message is used to either advertise network layer reachability information, meaning routing information, to a peer, or can be used to withdraw routing information from a peer. Withdrawing a route means that the route is no longer reachable. To save on network overhead, BGP organizes its route advertisements by common path attributes. In this way, routes originating from the same source, which have all the same attributes, will be advertised together in the same update message. The withdrawn routes field and path attributes field are variable length fields. It's possible for one or both of the fields to be 0 length and completely missing from the update message. Because of this, the first 2 octets of the message are the length of the withdrawn routes field. Then the following variable length field includes the information for those withdrawn routes. The following 2 octets of the message are the length of the path attributes field. Finally, the last field is also variable length and includes the NLRIs for the routes which share the path attributes described in the previous field. A length field for the NLRIs is not needed since the BGP message header includes a length field that describes the total length of the message, and this is the last field of the message. Let's now move on to the simplest of the BGP messages, the keep alive message. When I said the keep alive message is simple, I really meant it. The keep alive message only includes the BGP header and nothing else. As such, the keep alive is 19 octets long. As you might expect, the keep alive message is also used to let the peer know that the sending device is still alive and well. As mentioned in the open message, the peers only exchange dead timer values. They don't actually exchange a hello or keep alive timer value. The keep alives are sent every 1/3 of the dead time. For example, if the dead time is set to 90 seconds, then the keep alives will be sent every 30 seconds. It is possible to configure a peering relationship to not exchange any keep alives. If the dead time is set to 0, then no keep alives will be exchanged at all. Let's move on now to the last BGP message type, the notification message. The BGP notification message is sent to indicate to the other router that the BGP peering session should be destroyed. This could occur at many points in the BGP peer lifecycle and can signify that an error occurred or that the peering session was administratively removed or disabled. The notification message includes 1 octet for the error code and another octet for the error subcode. These are used to indicate the reason for the notification message being sent. The data field is a variable length field, which may or may not include any information at all. This field can be used by the router to include additional information about the error or reason for the notification. Though, as the network administrators, we typically aren't concerned with the contents of this field. And that's it. I appreciate you sticking around to review the detailed operation and format of the 4 BGP message types. I hope that this lesson has been informative for you, and I would like to thank you for viewing.